Hello, welcome back to Learn It from a Layman. I am Carl Christensen, joined tonight just by Cameron. Cameron, welcome back. I think you've missed a podcast or two, and with the traveling that was done a few weeks ago, seems like quite a while since you've been on, so welcome.
Thank you. It's nice to be here, be heard.
That's right.
We've got
a lot of people listening, and a few of them even care. So, tonight we're going to be talking about, or this afternoon or this morning, whenever you're listening to it, you're going to be listening to us discuss the basics of memory. So we did the physiology of the brain, I don't know, a year or two ago with Dr. Jonny. And Jonny might join us for this podcast a little bit later. He's got some things he's currently doing. And so in lieu of having Jonny, you get my research. But this, the basics of memory, will have some to do with some, biology and physiology, but mostly we're going to be talking about psychology and even some degree something I'm a little bit more familiar with, which is computer science. So we're talking about human memory, but as some of the subjects that we're going to be discussing in this podcast are storage, retrieval, encoding, all things that are very familiar to me in the computer science world. So let's start, I guess, at how does memory work inside our brain? So like I said, that's more along the lines of physiology of the brain. Cameron, were you on the Physiology of the Brain podcast?
I think I was. I believe I was.
And we talked about different neurons and stuff like that. Sounds familiar,
yeah,
right?
We talked about neurons and how they're sheathed like myelin and unmyelinated, and
right.
The sodium and potassium gates and how that's how the charges are sent through the neurons.
Right. Yeah.
Right. So basic biology stuff.
So we're not gonna dial that good. That's a good memory. That's more than I remembered. But we're not going to delve as deeply into, obviously, the physiology of the brain because we're talking about memory. But a few of the things we did mention there, we're talking about neurons, but also different areas of the brain. I know we discussed that a little bit. But different parts of our brain. So in 100 years ago, 200 years ago, kind of thought doctors, scientists kind of thought that that memories were stored in like one location in the brain or something along those lines. It's no longer the case that we believe that, or the scientists have essentially they've done research that shows that's not true. Different parts of the brain remember different things, and that's your different areas of the brain that are specialized for a particular task, language, images, those types of things. So when you're recalling information, usually it's the whole brain is lighting up, and by lighting up we mean there's activity, electrical activity, blood flow, and your whole brain, because you're accessing a full memory. It usually includes images, potentially emotions, scent, all those different things. So lots of your brain is going to work here. So the assembly process of how you get a memory out of your brain, as far as what I was able to figure out doing the research, is that's still a little bit fuzzy. Scientists aren't entirely clear on how we assemble parts, constituent parts of a memory, and put them back together. But there are some very clear things in the research, both in the psychology and biology, that science is quite clear on. So we're going to be just talking about some of that. For example, sensory input. So when we're experiencing things, be it touching or seeing or feeling or tasting, the sensory input goes into a part of our brain called the hippocampus, which works with the frontal cortex, and they together kind of do the remembering. And I believe also in our podcast before from our physiology of the brain, we just discussed kind of dreams and how during sleep the hippocampus kind of replays memories. So it's going through the process of figuring out what to store and how to store it. But we do know that certain areas of the brain, and the hippocampus is an important part in taking in sensory information, working with the the frontal cortex in order to figure out how to structure and whether or not to store it. So in memory, there's a lot of like I said, there's kind of separate areas that you can look ways that you can view this, kind of different paradigms. You can look at it from the biological perspective, which is kind of at the cell level, the neuron level. You can look at more at the procedural level, like different steps that we go through in creating and then recalling a memory. So let's look at a little bit of the biology. So it says nerve cells connect with other cells at a point called a synapse. All the action in your brain occurs at these synapses, and so that's kind of, Cameron was talking about that. That's the electrical firing of a pulse across the gap triggers the release of chemical messengers called neurotransmitters. Neurotransmitters diffuse across the space between cells, attaching themselves to neighboring cells, and each brain cell can form thousands of links, giving a typical brain about 100 trillion synapses. The parts of the brain cells that receive these electric impulses are called dendrites, feathery tips of the brain cells that reach out to the neighboring brain cells. So the connections between brain cells aren't set in concrete. So that's the plasticity, and that's a very important part in memory, and also just obviously in throughout life, being able to train your mind. So these connections between your brain change over time. Brain cells work together in a network, organizing themselves into groups, and then they specialize in different kinds of information.
Different chemical, the different, I'm trying to think of the name. The chemical things that flow between the synapses. You said the word just a second ago. There's different ones that do different things, if that makes sense. So it's not just like you have just chemical A. You'll have let's say 10 different chemicals in a synapse that will transfer over to the other synapses in the dendrite area. So
so there's
synapses. Yeah, like one synapse can innervate several other dendrites that will shoot along. So
these synapses are incredibly important, and that's kind of where the memories live. I mean, those connections and the way that those connections are made. So the more signals that are sent on the synapses, the stronger the connection grows between these cells. And thus, with each new experience, your brain slightly rewires its physical structure. In fact, how you use your brain helps determine how your brain is organized. And so that's where memory comes down, right? So your memories are essentially the structure of your brain, and the way that you've organized it, or the way that environment has organized it, and or the way that genetic pre-encoded information has also organized it. So there's a lot that goes into it, but so that's kind of more the biological look at what's going on in the brain, and the way that the cells are being manipulated as you have experiences. But there's still a lot of fuzziness, like I said, and what I was able to understand, that it's not entirely clear on how all of these things work together, as far as recalling and even encoding the information, that it is done, and that there are particular areas that certain information gets encoded is clear, but how it's getting pulled apart, what information gets stored in what order, and all those types of things is as of yet not entirely clear. So let's talk a little bit more about the procedural stuff. That's a little more clear to me, and a little more pertinent, I feel, to what I'm familiar with as a computer scientist. And that's more like you're talking input. So you have your encoding, and we've talked a lot about encoding in our podcast in the past, between the computer science podcast that we've done, linguistic podcasts that we've done, all those types of things, where you have a particular set of information, and you need to translate that into a different language. Essentially, that's what an encoding is. It's just a different. It's a representation of information or data in order to store it in a particular format, and in our brain, it's in a biological format, right? It's in these synapses. So where storage is an important part of understanding how memory works. And so we have in our storage in our brains, we have sensory storage, we have short-term storage, and long-term storage. So sensory is just that, literally the information that you get from your senses. Most of it comes in and goes out, and it is not stored for any more than a split second or two. It's just like when you're looking around your room, how much of it are you actually taking in? Well, your senses are taking it all in. How much is actually being encoded and stored? Very, very little, right? So it says what scientists aren't sure about is whether stimuli are screened out during the sensory input stage or only after the brain processes its significance. What we do know is that how you pay attention to information may be the most important factor on how much you actually remember. Mental context in which a person receives an event affects how the mind organizes the memories of that event. And we'll talk about that in a couple other scenarios that you might already be wondering about, like flashbulb memories and things like that. We're going to get to that later in the podcast. But right now, once again, you can just imagine panning the room. Your eyes are seeing, they're getting photons from everywhere, right? You're getting all of that information sensory wise, but as far as encoding and then storage, you're not doing much with it. You're doing almost nothing with it. And like I said, so scientists aren't sure whether or not it's screened out during sensory input, or if there's some type of encoding, some type of check of significance before it gets tossed. But regardless, it's there and it's gone. It's very ephemeral. However, like it said, the more you pay attention, the more you remember. And obviously, right, that's something that the layman knows. Obviously, if you're paying attention, you're going to remember more, right? So if you're watching the whodunit murder mystery on TV and you're paying really close attention because you want to get it before, the detective gets it, maybe you're picking up on things because you're really dialed into it. And so that's just an example of how paying attention matters. Tim just joined us also, and I'm sure he can tell us that paying attention in class is very important in remembering what the teacher said. Tim, do your students all pay attention to you during class, and does the amount of attention that they give to you affect the way that they perform on tests?
Wait, what was that? Sorry. Just kidding. Yeah. Attention. Yeah. Yes, absolutely. Not all students pay attention to the same degree, and yeah, there's a definite correlation between amount of attention paid and performance. Though it's not a one-to-one,
No, it's not. Right. And we'll talk a little bit about that as well, because there are people that are just more gifted memory-wise, right? That kid that sits in class with the head down, feels like, or he or she is just not engaged, and then does ace the test. And there are people that are just more gifted in the way that they can retain and retrieve information. However, everyone can take what they have and do better with it. And so that's another theme of this podcast I'd like everyone to take from this. We're talking about memory. And the general idea is that there are ways to get better, to improve, and to use the whatever structure your brain's in, whatever genetic predisposition you had to recall particular information. You can always use that to its most full extent by particular methods. And so we'll talk a little bit about that. But once again, encoding.
My method in school was not pay attention to the teacher and just read the book.
Well, reading the book is certainly important. But yeah, there's so encoding once again is important, and that's a transfer of data from sensory input into kind of a more brain-friendly format, right? And what exactly that looks like, it isn't like it's binary, right? We're not processing things in binary like a computer is. But there is some translation of sensory input from the nerves, electrical impulses, whatever it might be, into some type of synapse creation in the brain. But so we talked a little bit about sensory input, and then there's short-term memory, and that's something a lot of us are familiar with. Says so. There's these two scientists, Atkinson and Schriffen. They said that information is encoded acoustically, is primarily stored in short-term memory, and is only kept there through constant repetition. Short-term memory only lasts between 15 and 30 seconds, and short-term memory only stores between 5 and 9 items of information, with 7 items being the average number. So that was a paper that I was reading about that talked a little bit about them, but most of that's generally understood and accepted information about short-term memory from different studies throughout the years. So once again, short-term memory usually lasts between 15 and 30 seconds, right? And we could do a demonstration. If I told Tim a number, let's say it's 3982912. What are the chances?
912.
Right. So he just kicked that right back, right? Because that's stored in his short-term memory. He was paying attention. Now, if I talk now for another minute or two, and then I ask him that number again, Tim, what was that number again?
3981912.
And that was incorrect, right? So the first time, if I'm not mistaken, he got it correct. I'd have to go back and listen because I wasn't paying attention. But the second time, he got it incorrect, and that's once again your short-term memory starting to lag, and you're forgetting. And we're going to talk a little bit about forgetting and how that works. But yeah, short-term memory between 15 and 30 seconds, and generally somewhere between 5 and 9 pieces of information. Now,
I was going to say that's why in the U.S. phone numbers are 7 digits.
Right.
Yeah.
Because most people live in the same area code, so that's 3 digits that you'll remember fairly well because it's in your long term, and then you have your 5 digits or your 7 digits for the rest.
Right.
So
right.
It sticks in your head pretty well.
And if you think about other numbers like a social security number, they clump them in small, so you can remember a cluster of 3, a cluster of 2, cluster of 3, easier to remember.
Yes.
Than a cluster
of
8.
Right, exactly. And that's an important part, and that's something called chunking. And that can be across information. So we're talking numbers, phone numbers, or whatever it might be. If you can chunk it, and chunks are meaningful units of data, all of a sudden it's not 9 individual digits that you have to remember. It's, like Cameron said, you've got 3 chunks you have to remember. And that's much easier, right? So then all of a sudden, instead of a short phone number, you can remember a longer phone number if it's chunked up into different pieces.
And Carl, can I insert one thing about short-term memory and attention before we move on? It's you may have experienced this, but your short-term memory is actually functioning, even if you're not, for example, paying attention. So a teacher tries to get that student who they can know their mind is wandering, and they'll say, "What did I just say?" Because they know the student wasn't paying attention, and then the student rattles right off the thing they just said. What they're doing is, even though they weren't paying attention, that or at least not 100% of attention, that short-term memory is still retrievable for them, and so they'll if you've ever been frustrated because someone wasn't listening and you did the old "what did I just say" trick, that's people or you may have been bailed out, you weren't paying attention, and then someone calls you on it, and you just go back and retrieve that last 15 seconds or whatever of short-term memory, even though you weren't paying attention. It's a fun little experiment. You ought to try it sometime.
That's really good. That's because the next thing we're going to talk about here in a minute is the difference between conscious and subconscious memory. And
I've never been able to do that.
Really? What did I
well,
that's
if I'm not paid attention, then I just don't remember.
Yeah. Well, I think it's I think if you're purely not paying attention, then you wouldn't be able to, right? You still have to have some part of you, but people multitasking or that kind of thing. But I'm sure for everyone it's different.
Yep. And like I said, we're going to come back to that in just a minute. But let's finish off. So we talked about short-term, and then there's long-term memory. And long-term memory is what we think about when we say the word memory. That's kind of what we're thinking about. In computer context, it would be the hard disk. That's the long-term memories, the things stored that you can access anytime, right? The RAM, or the random access memory, that's your stuff that you can access while the computer's turned on, but as soon as you turn it off and load it back up, it's gone. And that's your short-term memory. Your long-term memory is there, and it's there to stay. So it says it has immense storage capacity, and information stored within long-term memory can be stored there indefinitely. Information that is encoded semantically is primarily stored in LTM. LTM is long-term memory. So semantic encoding, once again, that's the meaning. That's what semantic means, right? So information that you can encode via meaning is primarily stored in long-term memory, and that's important. We're going to talk about that a little bit more. But LTM also stores visually or acoustically encoded information. But once again, primarily semantic information. So you'll have images that from a long time ago. You'll have even words that people said to you from a long time ago that you can remember, phrases. But by and large, the things that you remember throughout your life are things that have meaning, things that you have kind of context around, and you have some type of framework, not just flashbulb memories, which once again we'll hit on in just a minute. But so if you want to store something for the long term, you need to understand the context and the meaning, and give it some type of a framework on which to be encoded. Information in isolation is that kind of that ephemeral, that very.
LTM?
What was that?
Is there olfactory LTM?
You mean, right? Is that the whole scent and memory thing, right?
Yeah, like a certain scent will invoke memories, or
right,
things like that.
Yeah, I was going to do a little more research into that. I didn't dive into that too much, but it is the case that I did see that, like I said, lots of different parts of the of memories are taken from different parts of the brain, and so a scent might
affect Dr. Jonny.
Yeah, that would probably help. But I would imagine a scent that will then cue other synapses in other part of your brain to fire, evoking a particular image or something like that. So, yeah, I didn't dig into that too much, but that's a good question.
So Cameron, I have heard something along those lines, that sense of smell is like has a strong connection to memory. And like, that's why, you smell something and it instantly transports you back to a certain place or time. And I've heard it theorized that there might be an evolutionary purpose behind that your sense of smell is closely linked to your sense of taste. And so, a strong association would help people to remember and avoid, a dangerous food. Anyways, that it could be kind of a link to survival. So anyways, I have no research to verify that, but I do remember hearing or reading that somewhere. And so, someone.
We love passing on hearsay on Learn It From a Layman.
Absolutely. Or in this case, smell say.
Smell say.
My sister-in-law used to wear perfume, and everyone thought it smelled really good. And I was like, it reminds me of old ladies. And because I realized it made me think of our grandma. So.
Okay. Well, on the list of things not to say to your sister-in-law is you smell like an old lady. So.
Yeah.
Also to your wife, don't say that.
Okay. Jumping back in. So, yes, olfactory scent information in memory is certainly stored. And yeah, the strength at which it's stored, yeah, it might have something to do with biology, but that would be a question for a doctor.
Would make sense, though.
It does make some sense, doesn't it? And that's why we like to pass on folk etymology. Well, this is, you know what I mean.
Especially when your folk etymology, whatever, also is a pun.
Is it a pun?
See, makes sense.
Oh boy. Okay. Retrieval. Let's move on now. We need to move on. The retrieval of information. So we've got encoding, we've got storage, and now I've got retrieval. And so now, it's stored in your brain, right? The synapses are there, the memories are stored, they're encoded. It says due to their differences, information stored in short-term memory and long-term memory are retrieved differently. While short-term memory is retrieved in the order in which it is stored, for example, a sequential list of numbers, long-term memory is retrieved through association. Remembering where you parked your car by returning to the entrance through which you accessed a shopping mall. So it's you're looking for context there versus short-term memory where you're just trying to spew. It's just it's a list of information and you're taking it from the front to the back. So, and that's once again, if you take it kind of more into the computer science world, you can see that you have memories where you have ultra high precision, or you have and that means you remember exactly what happened, or you have memories where you have a lot of recall and not a lot of precision. And recall is just the amount of information that you can remember. So if you're cramming for a test, it might give you high precision, right? You might exactly remember the date that this happened, or the date that happened, or a particular formula, those types of things. But low recall, right? The amount of additional information that you know beyond the information that you crammed is essentially zero. And your ability to recall that in the future also not great. So, however, if you're looking at remembering a favorite class, let's say you have a favorite class. Tim and I took astronomy, not at the same time, though Tim thinks we did. We took the same.
That's what I remember.
We took the same astronomy class, right? And so it's a fun class. We both enjoyed it. So 10 years later, we can still remember a bunch of the information about it. Now, is the precision high? It is not, right? Tim remembers a lot of erroneous things.
Yeah, like the stars are made of cheese. Or was that the moon? I can't remember.
Oh boy. But the amount of information that we can recall, the fact that there are quasars and that they're background radiation and all those different things, we can recall a lot of the information that was discussed. It's not with a lot of precision, and so let's see, it says this has to do with how you've structured your memories. As we use contextual clues to recall information about past events, scientists have suggested that any process that changes our perception of that context can increase or reduce our ability to retrieve specific memories. So contextual clues matter, essentially is what that's saying. So once again, the way you structured your memories, usually in a semantic information about what they mean given a context. And so if you change some of that context, it reduces our ability to retrieve specific memories, like I just said. So that's how sometimes memories can degrade over time as particular parts of the context fade. So but the more that we, like I said, paid attention, those types of things, the more that we have seeded our memory with more better encoded information in long-term memory versus a short-term memory. And then therefore we can retrieve more, even if some of the context is starting to erode and the memories are starting to change. I said we were going to talk a little bit about conscious versus subconscious memory. And this is the dual process theory. So it says some behaviors and cognitive processes, such as decision making, are the products of two distinct cognitive processes, often called, this is like our quantum physics podcast where the names are not imaginative. It says they're called System 1 and System 2. Cool. Thanks, guys. System 1 is characterized by automatic unconscious thought. So this is like that example that Tim gave about the what did I just say? And then you can just regurgitate what they just said, because even though you weren't actually paying attention, you are unconsciously processing the words, right? It's kind of the mind control that you exert when you're talking, right? Like I'm talking, you're listening on a podcast, and even though, if I wanted to evoke a image of an elephant in your mind, I'll say the word elephant, and to some degree, I've evoked the image of an elephant in your mind. So that's part of this dual process theory. You've got this cognitive system that's just running. It's just going, processing, and it tosses, right? This is all going either in via sensory and or short-term memory, and most of it's getting tossed, right? Some degree, I hope, of this podcast is going to be more useful and more structured and more meaningful to you, and therefore you can encode it semantically, give it some meaning, some emotion, and therefore it gets stored in long-term memory. And so that system 1 is associated with memorization and recall of information, while system 2 describes more analytical or critical thinking. So system 2 relies on system 1. So that's, once again, the idea that in order to get into long-term memory, it goes into short-term memory first, right? And so, and then from there, we have to decide, our brain decides, hippocampus, and we'll talk about other parts of the brain that help with this as well, the amygdala, that help determine, okay, is this actually useful information, or am I going to toss it? And system 2 is that critical thinking, that analytical thinking, and that relies on getting information into our short-term memory and then deciding, oh yes, this is important. This is something I need to remember. This is a question on a test. This is information I'm going to need to use in the future. And so that's this dual process theory, is that we've got one system constantly running the system 2 that relies on system 1. System 2 is the critical thinking, and requires a lot of memorized knowledge, and it's intuitive, automatic judgments to be performed quickly and accurately. So that's a little bit about the difference between conscious and subconscious thought and memory, is that subconscious memory generally is come and go, right? It's a short-term memory. Conscious memory is when I want to remember something, and therefore I try to encode it in a particular way. So let's talk a little bit about a flashbulb memory, because you could say that kind of flies in the face of this idea that you have to encode information consciously in order to store it, because flashbulb memories happen to us. They aren't usually done on purpose, right? I have an example of a flashbulb memory. Cameron or Tim, do you have any instances of what a flashbulb memory, before we talk a little bit about I guess I should give the name says what it is, right? And most laymen know that a flashbulb memory is just a memory where you have a lot of detail about a particular, usually a very bounded amount of time, right? Be it an hour or 2 hours, where something usually highly emotional happens. Something incredibly out of the ordinary, something entirely unexpected, and therefore all of this information just gets shoved into long-term memory kind of simultaneously and without our desiring to do so. Tim or Cameron, examples or thoughts on flashbulb memories?
Yeah. I remember vividly one of my past lives, I was a butterfly.
Oh my word.
Wait, no, that's not what we were talking about.
All right. Well, that would be quite a flashbulb memory, wouldn't it?
Yeah, it's quite the flashbulb. I'm trying to think, like, there's definitely things in my memory, but I don't know. They've definitely all eroded. Like,
yeah, and that's something actually that most people think the flashbulb memories don't erode, and there have been studies that essentially show they erode just like any other memory. The flashbulb memories are fodder for getting tossed also. So, but I have a specific.
I would expect my wedding day to be a flashable memory, but it's not so much a flashable memory. I don't know. Maybe it's because I've been married for 15 years that I can't remember everything. So
It is a highly emotional day. It is, however, not an unexpected day. And I guess there are a couple elements to flashbulb memories. And one of the ones I was looking at and reading about was essentially people saying that you have to have some degree of unexpected or just there's a couple elements that kind of add to it. So just highly emotional will certainly help set it in your memory, but not in the same way that. Let me give you the example of my flashbulb memory. And Cameron, well, he actually won't remember this because while we were together for this experience, we were young enough that he wouldn't remember, and I do, even though I'm younger. And that's because I was at a museum in Illinois, and I was 3 years old. And I remember a few things about this. I remember walking in, and I remember with our parents, and I remember the tour guide saying, "Do not run in this museum." And I remember my little 3-year-old mind's thinking, they're talking to someone else. Like, in my mind, I truly remember the idea that, like, that doesn't apply to me. They were talking to that old man over there. He looks very likely to bolt at any moment.
Already at 3, you were the exceptional Ubermensch.
Yes, exactly. So now I'm going around this museum, and I find an item in the museum. It was a gun that I thought was very cool. I thought, my mom needs to see this. And so I'm looking at this gun, and I turn around. My mom's on the other side of the room, across the this museum room. And so I'm like, oh well, as a 3-year-old is then want, I start booking it. Right, I turn around and I accelerate 0 to 60 as fast as possible to go get my mom to show her this gun. And that's where my flashbulb memory takes a little break, because from what I'm told, I tripped on the corner of a rug and went headfirst into the corner of a table. And that, as you can imagine, is a bad thing to do. And I was, not to make anyone's weak stomach, there was some blood involved, and I don't remember anything until I don't know, 5 minutes later. I remember being, at this point, I'm now seated on my mom's lap, and she's talking to someone, and then there's something being held to my head, and I don't know what we were doing and sitting in a chair. I do remember thinking that was weird. Like, why aren't we doing something about this pain in my head? Flashbulb memory cuts, and now all of a sudden I'm in the hospital, laying there in a crib, and the doctor is stitching me up while a nurse is trying to distract me with a hand puppet and candy. And this is when I'm 3 years old. I have all of these memories, all of these details, so much of this that I remember incredibly vividly. And that's a flashbulb memory, right? And so that's an example of when 3-year-old. I don't have other 3-year-old memories, or at least none that I can directly trace to a 3-year-old version of myself. But that one, not only can I trace, I can tell you what the weather was outside, and what hospital we went to, and words that were said to me, and things like that. So, and once again, that's this heightened emotion, incredibly potentially could have been life-changing. It wasn't, but event that where everyone around me was also heightened emotionally suddenly. And the interesting part to me is that it encoded information even further back. Like it's preceding the event. I still remember things that I obviously otherwise would have forgotten. So but let's read a little bit about, so it says, neuroimaging has shown scientists that the purpose of encoding and retrieving bad memories involves the parts of our brain that process emotions, specifically the amygdala and the orbitofrontal cortex. It seems the stronger the emotions associated with the memory, the more detail we will recall. Like I said, it was
just so you know, I do remember being annoyed sitting in the car waiting for you at the hospital.
There we go. Yeah, so maybe there's a small amount of memory, but like I said, it was heightened emotion for everyone, so Cameron might be able to remember a little bit. But it says the accuracy of retrieval declines over time for flashbulb memories, in the same way as for everyday memories. Younger people are generally more likely to form flashbulb memories than older people. So Tim, you're out of luck.
Carl, you just made a flashbulb memory for me with that passive-aggressive jab.
That was just aggressive. There was nothing passive about it.
Yeah, that's right. Nothing passive there.
What was that, Cameron?
I said straight up aggression.
That's right. I got to make this a real flashbulb memory for Tim. Okay, so it says Brown. So two researchers, Brown and Kulik, I believe, argued that experiences and events which exceeded the critical levels of consequentiality and surprise caused the mechanism that creates this flashbulb memory to register a permanent record of the event. Surprise refers not to anticipating the event, and consequentiality refers to the level of importance of the event. Since that's kind of what I was saying, Cameron, as far as that your wedding day is incredibly important, but it's also not a surprise, at least not for most people, right? Vegas weddings aside, your wedding day is something you probably knew about months in advance, and therefore, when it comes up, it's an important day. However, it's not a unexpected day, and so this element of surprise kind of creates these flashbulb memories in the way that, for example, 9/11. That's a flashbulb memory for almost everyone in the United States, right? You know where you were. You can remember lots of information about that day because it not only was it incredibly emotional, it was also a massive surprise. So that's an example of a flashbulb memory that most people listening to this have. There are other Princess Diana, the car accident there, right? I remember that as well. Another kind of flashbulb memory. So let's see. Let's move on now to forgetting. So that's an part of memory that we all experience, and some, Tim, a little bit more than others. Mm-hmm. So let's talk about what that means. The idea of forgetting can mean different things. So you say if you've forgotten where you put your glasses, you probably didn't actually forget. It was just never encoded at all. Like if you tried to remember something one time and couldn't, but then later remembered, that is probably a mismatch between retrieval cues and the encoding of the information that you were searching for. So that's like trying to find if you do a search on Google and you find exactly what you're looking for, and then a week later you're like, oh, hey, I found this article, and so you try to remember what you searched for and you can't bring it back, right? You're like, I don't remember what I searched for and how I got that information. So that's kind of this idea of a memory that, you know that it's in there, but you can't recall it because the mechanism that you use to pull it back is, the cues that you used are not matching that information, and therefore you can't pull it up, right? That's the tip of the tongue type of sensation. Like, I know it's in there, but I can't get it. And that's these mismatch between retrieval cues. And as a lot of people know, one of the ways to help that is helping context. You give it more context. You put yourself in a similar context when the last time you can remember it, or the original event. You put yourself in that context, and that aids memory, that aids recall. So let's see. It says if you we're talking about a little bit about actual suppression of memory. It said the researchers found that a person can suppress a memory or force it out of awareness by using a part of the brain known as the dorsolateral prefrontal cortex to inhibit activity in the hippocampus. That's pretty wild to me. And I was doing some reading about that, and that's the idea that you can purposefully suppress memory. I guess that's kind of what I do when I think about Tim, but
just kidding. About myself too. See how I got you back there, and now I made you feel bad about it.
Yeah, that's true. I usually feel bad because I like Tim a lot, but I try to give this. There's got to be this, a foil. There needs to be a foil in the podcast. So,
Carl gets all of his ideas from Russian novels.
I come by it honestly. My dad loved Russian novels. All right. So yeah, the idea that you can suppress a memory and that there's a part of your brain that can do it. This dorsolateral prefrontal cortex is pretty awesome. And there are other ways. Is you can also substitute memory, so people can redirect their consciousness towards an alternative memory. And they do this by using two regions. That's the prefrontal cortex and two parts of the prefrontal cortex: the caudal, I'm going to mispronounce these, but forgive me, and the mid-ventrolateral prefrontal cortex. And those areas are important for bringing specific memories into the conscious mind, and therefore you can use them to distract memories. And so there's this whole research thing I was looking into about it, but essentially suppressing memory involves shutting down parts of the brain that are involved in recall. To substitute a memory, those same regions must be actively engaged in redirecting the memory towards a more attractive target. So this is useful really, for example, in like PTSD. People that have these incredibly highly emotional and traumatic events, they can use these methodologies. So this is like a psychologist would help them do this to essentially redirect their memory away from a particular element or a particular memory, and take that context and essentially repurpose it, so that they can't. You're suppressing that memory, that the thing that created that PTSD. You're going to suppress it, and you're going to do it on purpose, and you're going to use parts of your brain to do it. And so, if you need that, I recommend going and seeing a psychologist. Dr. Jonny just joined. Jonny, we're talking about ways that you can suppress memory, and there are lots of parts of the brain apparently that can be used to suppress memory. Do you know what the mid-ventrolateral prefrontal cortex is?
Yes, that's the part that if you hit hard enough with a baseball bat, you immediately forget everything.
Whoa. Jonny got his medical degree from the mafia. All right, Vito, we've got to whack his mid-lateral prefrontal cortex. Here's a bat.
All of those words are just directional terms to describe the area of the brain that it's at.
Okay.
So it's kind of in the front.
Yeah. Get that from frontal. The rest of them are unclear to me. Lateral, I can get it as well. But how can it be frontal and lateral? That seems confusing.
Because it's in the front and side. So it's not
It's
all the
side
way
of
on
the
the
front.
side. It's not always on the front. It's on the side front.
All right. Yeah. So, okay. So let's talk. Oh, so Jonny, we're talking about forgetting right now, and so the idea that so there's a researcher in 1885, man named Hermann Ebbinghaus, conducted an experiment in which he tested how well individuals remembered a list of nonsense syllables over increasingly longer periods of time. Using the results of his experiment, he created what is known as the Ebbinghaus forgetting curve. He concluded that the rate at which your memory or recently learned information decays depends both on the time that's elapsed following your learning experience, as well as how strong your memory is. So once again, there's elements beyond. This is how different people can recall different things for longer just because of their innate ability. So, but yeah, this idea once again of blocking out specific memories as opposed to forgetting, those are different ideas. Forgetting is a natural curve, like we saw, but there are methodologies we can use to block out specific memories. And then there's blocking out specific memories that happens in kind of a non-conscious way. So Freud suggested that humans have a mechanism that they can use to block unwanted memories. And it says neuroimaging studies have observed that which brain systems play a part in deliberate forgetting, and the brain will sometimes hide particularly stressful, traumatic memories, and it be for protection. If it's having and you've probably seen this, it reminds me of the movie K-Pax. We always have to invoke a movie. The idea that in K-Pax, I can spoil K-Pax, right? It's like 25 years old and it has Kevin Spacey. I'm sorry. It does.
Oh.
Yeah. Well, whatever. He's in there. So is Jeff Bridges, though. So, makes up for it. the idea there is that it's unclear in the movie whether or not this main character, Kevin Spacey, is actually an alien, and it's still actually unclear in reality as whether or not Kevin Spacey is an alien. But in the movie, it's unclear because Kevin Spacey acts like this alien that has all these some amazing ability to do some. He has some kind of savant-esque abilities with astronomy and things like that, and acts very weird and unique. And he says that's because he's from a different planet. The Jeff Bridges character is a psychologist, tries to work through whether or not this is true, whether the guy's just crazy, whether or not he's got anyway. And at some point, he puts him under hypnosis and accesses memories of an event that was incredibly traumatic, where there was murder and anyway, I won't take you through the whole plot of the movie, but generally through this hypnosis event, he accesses subconscious memories that have been blocked because of the effect they were having on the conscious state of this individual. So, and that is something that I've seen occasionally in real life, not to that extent, but just the idea that particular events can and are blocked out because of the traumatic nature of those events. So obviously both happen. There's PTSD where they don't get blocked, and we'd like to block them, so you can do that on purpose. Or there are these events that your brain, for whatever reason, can and does protect you from, and just purposefully hides. And so that's a pretty awesome.
That's something that you see in the medical field, especially with events that happen to young kids. The brain doesn't, the way I like to think about it is the brain doesn't really know how to process that information, so it hides it away. And then a lot of times you see these things will resurface when people get older. These childhood traumas and things, they'll start to remember them, and it's very difficult. But the brain starts to actually process those and release those memories. So they're like hidden in the brain and you can't remember them. But it's a defense mechanism, because it's probably not very good for your survival to remember a bunch of traumatic things that happened in your childhood. You know, if we think about the brain as developing more and more over time to help us with our survival, that forgetfulness or that shadowing of memories that the brain does is actually a pretty amazing thing, you know, that can help you overcome that trauma and until a time when later on you can better process it.
Yeah, for sure. And that's pretty it's pretty crazy that the built-in mechanisms there. So let's hit a couple more things before we wrap up here. So do memories change? Long story short, the answer is yes. Storage, just like storage is lossy. It's not perfect, and retrieval can, like I said, we need a lot of recall with low precision or vice versa. So the idea that you have a perfectly encoded memory and it stays that way is well, it's not true. The more we dwell on a memory, however, or rehearse specific events surrounding the memory, the stronger these neural connections become. So the idea that we can recall particular events for our whole life is true, but memories do, particular contextual elements can change. And you see that obviously in criminal law all the time, where they have particular memory of events, and you ask them under a lie detector test, that's true, right? But then you can show that their memory is wrong, right? That is not actually the way that something happened. And so memories can change, and they can be affected by other things. So it says for a long time, people thought that the older the memory, the more fixed it is. That's not necessarily true. It's just the more times we revisit a memory. But when we do revisit a memory, and this maybe you've heard before, when you access a memory, you're also making it flexible again. The connections, from what I read, the connections appear to become malleable, and then they reset. So the memory can change a little each time we recall it, and it resets stronger and more vividly with every recall, but some of that malleability and plasticity around it as you're recalling it can actually affect the memory itself. So be careful.
Yeah. I was actually watching an interview with Paul Rudd, and he actually mentioned that he tells people that he got into acting because of such and such a thing. And he said, I'm not sure if that's true anymore or if it's just a lie that I've created because it was an easy answer. And now that's just what I always say.
Yeah.
So.
Good example. All right, so two more things.
It seems like the more traumatic the event is as well, that those memories can seem to shift and sway a lot more than, something that's, that your brain isn't processing, that's not quite as traumatic. It seems like all those emotional centers, when they're fired up, and you're not using like your frontal cortex or these memory building centers or your logical brain to work through a problem or think through something. If you're using all these emotional things, then a lot of the emotions will stick with the memory, but the circumstances can kind of shift a little bit more because the memory isn't quite as crisp.
Right. Yeah, that makes sense. Okay, two more things we're going to touch out. We're hitting an hour here, and we don't ever want to take our podcast too much like past an hour because nobody wants to listen to us too much past an hour. One of the two
people that subscribe to listen to this nonsense.
Hey, how dare you? Some people have a photographic memory? And so this I was looking up, and you've heard anecdotally, and maybe you know people anecdotally that have a photographic memory. In most cases, from what I've read, it's just people have better memories or worse memories. It's not photographic in the way that, well, a photograph is, right? No one actually recalls every detail of everything all the time, with some kind of exceptions. And the name for these people are highly superior autobiographical memory. That's for the condition, highly superior autobiographical memory. It's a condition that has been identified in fewer than 100 people worldwide. So very, very rarely do you find one of these people that can recall a specific day 10 years ago. They can tell you the weather. They can tell you what they ate for breakfast. They can tell. And so, you've read stories about that in news articles. There's fewer than 100 of these people in the world, as far as people that we've actually identified, at least. But yeah, so these people are incredibly rare. The memories are exceptional, but not as good as actual photographs. And doctors don't entirely understand yet what, as far as what I've been reading, what their brains are doing, because in research and there's nothing that they can see that's that different. So it says there's no particular ability that appears to underpin the condition. Results from one study suggest that people with HSAM, and that's this ability to recall everything, are no better at acquiring memories. So they're not actually better learners. They just store everything. So a very unique condition, but the idea of a photographic memory in general is kind of unverified. The idea that it exists en masse in the population and that certain people just can take a picture of that's not the case. There's this idea of eidetic memory is similar to that of a photographic memory, but not exactly the same. It's the ability to vividly recall an image you're exposed to, but only briefly. But that's a little bit different than a photographic memory.
It's kind of the converse, right? Photographic memory, you're not any better at forming the memories, but you can keep it forever. The eidetic or whatever memory, you're incredible at forming it, but you only keep it for
potentially
a while.
Right. Yeah. And so apparently there's ways that you can train yourself to do this. There's like a military method. There's that you can kind of teach yourself how to recall information in kind of a more photographic way. there are, I mean, you can eat well to better form memory, but that's how we're going to finish the podcast here, is what ways you can improve. So we've talked about a lot about memory, but most of us want to just know how can we improve it, whether or not it's for school or just in life. We want to better recall things. And I think kind of the overarching point is just the more you inform yourself, the better kind of context you can give information, kind of the mind palace type of situation where you can put things in a particular location because you have context for it. That's the best way, and chunking is the more that you understand about the world around you, the better you can chunk the information, in which case it's easier to store. But as far as particular methodologies, and Tim might be familiar with some of these, as all educators probably are. So that's in teaching, testing can help. Testing can and does help memory. And I'd dive into that more, but we're going to talk about a couple more here. Spacing. So obviously you can't, this is the idea that cramming just a 3-hour session of getting ready for a test doesn't actually help your long-term memory as much as spacing material out over a prolonged time span. Something called interleaving. It's a teaching technique. It's alternative, it says, to blocking. Blocking refers to a student practices one skill or topic at a time. Interleaving is when students practice multiple related skills at the same session. This technique is proven to be more successful than traditional blocking in various fields. So the idea that you're doing multiple things as opposed to just one thing.
Can you give an example of that? Like, I'm thinking
I'd imagine it's something like, I'm thinking actually sports in this case. You know, if you are trying to get your someone to learn how to throw a ball better, you don't want to isolate the wrist and work just on the wrist, because that actually doesn't help that whole the muscle memories. They all need to go together. And so the idea that you want them to go through the whole motion again and again, and that will actually help individually the wrist better than isolating the wrist. That's probably also the case with in if I'm studying a language, I don't want to just hit vocabulary. I want to put it in context of a conversation, right? Something along those lines.
Okay, cool.
So that's on the teaching end. On the learning end, you want to do something called state-dependent memory. Refers to the idea that being in the same state in which you learned information enables you to better remember that information. So we talked about that a little bit earlier. Put yourself in the same situation. That's like in a dream. If you want to remember a dream and you're forgetting it, go lay down in your bed, and you'll have a better chance of remembering it. That's also the case with other information as well. So schemas refer to the mental framework an individual creates to help them understand and organize new information. So once again, that's put this framework around it. So if you can put a schema together, that mnemonic device, whatever it might be, you can all of a sudden create a framework for this information as opposed to just trying to throw spaghetti at a wall. We know how that works. And then deliberate practice. And so that's, once again, just deciding that you need to do this as opposed to letting that system that passive short-term memory hopefully recall as much as you can. As you read along, it's actually taking the time to take notes, rewrite things again and again, say something again and again, as you continue. As you make that deliberate, conscious decision, you're encoding that information and strengthening that synapse. So
basically, Carl, you're telling me that good memory takes hard work.
That's ridiculous, Tim. That's of course not what I'm saying.
Oh, good. Phew.
Yes, generally the idea, once again, is that there will be people better or worse than you at remembering things, unless you're one of those 100 people that remember everything. But as far as learning goes and remembering things go in your life, you're always going to run into people that are either worse or better than you at remembering information or facts or statistics or whatever it might be. But if you want to improve your own ability, you can do that. I don't recommend phone apps. There might be some that help a little bit. Crosswords can help. They've shown a little bit, but it's contextual. It's more global than that. You have to put in time to remember things, and if you give it the right structure and the right schemas to build that information and code that information on, then you'll actually be able to remember things better than you did before.
And I can verify that about the phone apps. Memory is less about phone apps and more about synapse.
All right. That's just the worst way to finish this podcast.
Did I give anyone a flashbulb memory? Maybe so.
Okay.
That was a pity laugh.
Oh, man.
All right. Well, thank you, everyone. We will be renewing our World War II podcasts again here soon, hitting World War II Part 4. For those of you following that series, which, by the way, are pretty awesome. So if you haven't, go back and listen. You get some really cool information, for example, about like a dive bombing rogue squadron X-Wing in World War II. Or at least that's what I remember. So
that's what you encoded.
Yeah, is that memory changing? We'll never know.
That's right.
Yeah. Anyway, I'm sure there's more we could talk about here, and but we are going to wrap it up here, and we will talk to you next podcast.